Good morning and welcome to this 8th episode of our NIO Swift MUD tutorial series, where we're creating a multi-user dungeon game using the NIO framework and the Swift programming language. And today, our objective for today will be to allow our players to move from one room to another. So we're talking about movement. Before we're starting to do that, we first want to discuss two questions that were asked in the comments from one of the previous videos. And one was, when you look at this the main.swift file and you look at all this bootstrap code, it seems to be a lot of ceremony and a lot of settings for mostly default like values, because there aren't too many reasons why you would typically want to have these values any other way. So the question is, why aren't they set by default, and perhaps override them if required? I'm not really sure, but my best guess there is that NIO is intended as a low-level networking framework. So it's intended to allow lots of different types of network applications. We're doing text processing, where it's retrieving text and sending text back, but it could very well be files being sent over. It could be binary data. It should allow multiple protocols like TCP, but also UDP. So it's quite it's quite versatile and quite low level and quite generic. So I think that's one of the reasons why there are so many options to set in the specific way that these pipelines are handled. On the other hand, I think it would be valuable if there was at least some form of setting a sort of default, mostly good server, because when I was looking at the other examples in the NIO framework, almost all have more or less the same default values, and typically it's your custom handlers that vary. I think they all have a back pressure handler, so it seems that those could be safe. Those could be safe defaults, and I wouldn't be surprised if in a newer version of NIO these are added by default. The second question was regarding why an array in Swift isn't thread safe by default. So we have our sessions array here, and we require locking to protect it from being concurrently edited or read while it's being changed or changed while it's being read. So we added these locks to synchronize those activities. And the question is, why isn't an array in Swift thread safe by default? Some other languages already provide by default, or with very minimal additional effort. I think it's a great question. I think the main reason, I think there are two reasons. First off is, most code you would write in iOS development or macOS development tends to be, for the most part, single threaded. They will use background threads to do work, but typically the results of that work would be sent back to a main thread, for instance, to show on the screen. So there aren't that many situations where you would actually want an array to be manipulated by various threads at the same time. And the second one is, if I create a static variable called sessions within this class, to make it easy to access it from anywhere. So I then have a session storage sessions do, and I can append and I can read it and whatever. I more or less created a global variable, something that's not a particular tends not to be a particular good idea, because if it can be changed and read anywhere without any sort of discretion on how that's working, it's bound to add bugs at a later stage. So that's also why I'm hiding it as a private variable, and I just let the rest of the program interact with the session storage using an API. I use locking here to synchronize access to the array. There are probably better solutions. Locks have the disadvantage that they can lead to deadlocks if not used carefully. Not to say I'm using them carefully here, but for now I haven't seen any issue. I also did a bit of testing on how much is the overhead from first setting a lock and unlocking. I noticed I created an array and added 1,000,000 elements using locking and also using a one that doesn't use locking. It's negligible. We're talking about 4% or so performance penalty. So really nothing to worry about. What we do need to worry about is how can we get a player to move from one room to the other. And I think we should tackle this one top down. So the pattern we have is that we first define, come on mouse, we first define a verb, and for the command the player will be using. So we'll use the go command, and that will take a direction, and fortunately we have a type called direction. I think this one requires you to be logged in, because otherwise you don't have a player and you don't have a room you're in. So we actually don't need to add that because that's the default case. What we do need is the amount of words we expect. And we expect the word go and then a direction, something like go north or go up. And then we need to create the verb from the input. So let's see, we have a case look. We had the case look and we have a case go, and we say return, and I want to add a go and a direction. Our risk here is that we need a direction, and we only have a string coming in. So I would like to do something like string parts 1. Unfortunately, we only accept a direction here. So we need some way of transforming a direction, a string into a direction. I think the most elegant way of doing that is, let's just keep this here for now, is to have our direction enum able to understand a string, and it sort of already does, because we defined it here. The raw type for the enum is a string. You can already do something like, let's give an example. So you could say let direction equal direction raw value string. So that could be the string parts 1. And then we have an optional for direction. The disadvantage here is that this will only work if the correct capitalization is used for the string that's coming in. So if somebody types north, it'll work. If someone types north or whatever, it won't. I think the nicest way of handling that is to go to our direction and simply create an initializer that takes a string value, and it's an optional initializer or available initializer, because if the string value is not a valid direction, then we will return a nil. So we can say we have a capitalized string value dot capitalized. What this does is it changes something like north to north or north to north. So it capitalizes the first letter and lowercases the other ones. And then we have a self init. We can do a raw value of the capitalized string value. And this this returns an optional. So we could say we have our direction from a string value for our parts, the second word, and we now have an optional direction. I think that we should say we could guard unwrap this one, else we'll say we'll return an illegal string, but if it's correct we will return a go direction because it's now unwrapped. So we should now be able to at least parse the go command with a direction. And the next step would be to handle the actual command, and we can do that from the parse handler. So we have our look, we'll add a case for the go, and we'll have the direction as an associated value, and we'll say the response equals an await some function, and that we still need to create. So let's call this a go. It should be something like this, and it should also have a session, so we can send back the data to the player. An updated session and a direction. But we don't yet have a go function, so we'll go to our MUD helper functions and we'll start creating a go function. It'll take a session and it'll take a direction. It'll be an asynchronous function and it will return a MUD response. Okay, so now we need to do a couple of things. So the go command only works for a player. So let's first get our player. So we'll get the player from the session. We'll find the user from the session dot player ID. If this doesn't work, we'll return a MUD response for the session. And we'll say player not found in session. Okay, shouldn't happen, but still. We should also see if what the current room is the player in is. So we need to find a room for the player dot current room ID, else return MUD response could not find room player dot current room ID. We need the current room to check whether the direction you want to move in is a valid direction from the room you're currently in. So we need to find an exit in the current room, and we need to first exit where the direction equals the direction we want to move in. Else we again return a. It's getting a bit tedious, but that's just the way it works. I just want to be able to get as verbose an error message as possible. Now exit found in direction. So we now have our exit, and we now also need to find our target room. So we have our let target room equals an await room.find the exit target room ID else. We'll copy paste this one. Could not find target room. And if we find this target room, we at least know that we have a player. We know where the player is. We know the player can move in the correct direction, and we found the place the player could go to. So now we can start actually picking up the player and moving it into him into the or her into the correct new location. And I think the easiest way to do that is we have a player and it has a current room property, and we'll set it to the exit.current room target room ID. And then we save the player. And then we need to return a result. We'll say you moved into a new room. And it might be a nice idea to take our target room formatted description, so it's like directly looking around into the new room. I think this should be enough, but just let's give it a go. We still have a few. Yeah, okay, we could not find a room, and we'll silence these warnings for these optional values. Okay, let's run. Oh. This might be a property instead of a function. Okay, cool. And now let's give it another go. So it's still working. Still building. For some reason, the first build of the day always seems to take longer than the next ones. It's running. It's listening, so we can log in. So let's look around. Oh, first need to log in. I think we created a user called Foo. We're in a room, and there's an exit here, so we should go north. We're here in the first room, and then we move into the second room. There's nothing to see. At least is an exit going south. Okay, so this seems to work. If I close the session, log in again, and say go north, and it says it needs to be logged in. If I log in and I say go south, it says there's no exit found in this direction. So this seems to be working. I also want to get, by the way, I quickly want to get rid of this because it doesn't help us anymore at this time. I think that is something that was added in the response handler. I'll just quickly make a copy. I might need it in the future. We have our response message. Oh. Just a quick rebuild to see if this helps. It seems that the program is still running. So we need to, unfortunately, need to kill it manually. Okay, so now we have, fortunately, again have the, we're not seeing all that session data anymore. These spaces do annoy me. So I think we should get rid of those also very quickly. I think they're added because of the indentation here. So I think if we now run this again, okay, that's fixed as well. Well, for now, I think this is enough because we met our target for today, and that's to allow our players to move from one room to another. Next time, we'll start looking also at other players because we want to notify other players when something happens that might affect them. So if a player is in a room and another player enters that room, I think the player that's already there should get a message that that a new player entered the room, and the same for exiting rooms. And I think there are many places where you would want this kind of interaction. Perhaps you want to notify a player that another player is looking around. I think that's all up to you, but I think we need a system where we can start sending those kinds of notifications. And it means that we need to start being more aware about the logged in players, players in the room, and sending back exits. I think that's enough. Thanks very much and have a good day.